Let's say you see this kind of a simple question in your chemistry JAMB exam. How will you solve it? It is very simple. Let us solve it together. The question says the bond formed between H2O, that is water, and hydrogen ion to form H3O plus, which is also called hydroxonium ion, is what? This is a very simple question, and this is a chemical bonding question. So you can see the options. We have option A, covalent bond, electrovalent bond, ionic bond, and option D is dative or coordinate covalent bond. This is a very simple question, so let's get right into the explanation. So firstly, let us start with covalent bond. What is covalent bonding? Covalent bonding is just like a bonding whereby electrons are shared between the participating atoms. When you talk about bonding, bonding is just like a way in which atoms combine together to form compounds or molecules. I hope you are following me. So now you should know that bonding is a chemical property of a compound or of an element. So now what is this covalent bonding? Covalent bonding is a bonding whereby electrons that are taking part in the bonding are being shared most times equally between the participating atoms. For example, an example of a molecule that exhibits covalent bonding is hydrogen gas. Hydrogen gas. Also, oxygen gas. Many of the atomic molecules usually exhibit covalent bonding. Let me show you how it is. For example, now we all know that the atomic number of hydrogen is 1, right? That means it has 1 electron. So you can see that this is 2 hydrogen atoms for this hydrogen gas. It is made up of 2 hydrogen atoms. Let us say this is the hydrogen atom with 1 electron, and let us say this is the second one with 1 electron. So both of them, they want to access, or they want to get to a place where they are filled, where their shell is filled. You know, they want to get duplet, and this is the first shell. The maximum number of electrons in the first shell is 2. So they need to bond together. If they want to transfer the electron, it's not going to be easy. The best way these two atoms can bond is to share their electrons, so they can both have 2 electrons in their outermost shell. You know, hydrogen only has 1 shell, and this is the first shell. So we are now going to have something like this. When they bond together, they are going to share the electrons. You see, so it's going to be complete. They are both going to be having 2 electrons both in their outermost shell for this and for this. That is where we get something like hydrogen gas. This is also the same thing for oxygen gas as well. So oxygen gas, hydrogen gas, they both exhibit covalent bonding. So now let us move to the next one. The next one is electrovalent bonding. Don't be confused. Electrovalent bonding has another name, and the other name is ionic bonding. So it is either called electrovalent bonding or ionic bonding. So ionic bonding and electrovalent bonding, they mean the same thing. So now what is electrovalent or ionic bonding? Electrovalent or ionic bonding is a type of a bonding whereby an atom completely transfers electron to another atom to attain stability. Don't forget that I told you that the aim of chemical bonding is to attain stability for both, or it might be two atoms or 3 participating atoms or 4. You know, just for these atoms to attain stability to come together to become a compound. You get? So in an electrovalent or ionic bonding, a particular atom completely transfers an electron to another one. You get? It might be 2 electrons, it might be 3, it might be 1. You get? So an example of a compound that exhibits electrovalent or ionic bonding is sodium chloride, also potassium chloride as well. That's KCl. So let me show you how this works. Let us use sodium chloride as our example. Now, sodium, we all know that the atomic number of sodium is 11, right? 11. That means it's going to have 11 electrons. So in the first shell, it has 2 electrons, right? And in the second shell, it has 8 electrons, right? And in the third shell, it has 1 electron. Hope you are following me. That means it has 3 shells actually. In total, it has 3 shells. Don't forget that bonding is always dealing with the outermost shell. The outermost shell is also called the valence shell. The valence shell. So if you are asked in your chemistry JAMB exam that what is the valence shell? The valence shell is basically the outermost shell. Hope you get. And bonding deals with the outermost shell alone. Don't forget, I said bonding deals with the outermost shell of an atom alone. Don't forget that this is sodium, and the atomic number of sodium is 11. Are you getting me? And for this chlorine, the atomic number of chlorine is 17. I hope we all know that. So chlorine. Also, chlorine has 2 electrons in the first shell. it has 8 in the second shell, and in the third shell it has 7. So it also has 3 shells. So don't forget that I said that chemical bonding deals with the outermost shell. So in this outermost shell, you can see that it has 7 here. Chlorine has 7, while sodium has only 1. Don't forget that both of them, they want to attain octets. That means they want to have 8 electrons in their outermost shell. For this one, it has 1, and for this one, it has 7. You get? So this sodium can completely transfer this 1 electron to this chlorine. Are you getting it? It can completely transfer it. Let us try to draw the diagrammatical representation, but I'm only going to be drawing the valence shell. You get? So this is sodium with only 1 electron in the valence shell, and this is chlorine with how many? 7. 1, 2, 3, 4, 5, 6, 7. Hope you are following me. So this needs to lose this 1 electron. If it loses this 1 electron, it's going to the electronic configuration is going to be 2, 8. Without this one, this is already octet. Are you getting me? Why this one? It needs to become 288. Are you following me? So if you want to become 288, this has to transfer this 1 electron to this. So it will completely transfer this 1 electron to this. So this last shell is not going to have anything. Why? It's going to transfer this 1 electron to this other sodium. So it's going to be 8. It's going to be 8 at the chlorine side. So that is where you have something like sodium chloride. Sodium chloride, which is our normal table salt. I hope you get that. So now to the next one. Dative or coordinate covalent bonding. This is also a type of interatomic bonding. And what is spectacular about this type of bonding is that the electrons that are used in the bonding are only donated by 1 atom of the. Let me give you an example. Let's say we have 2 participating atoms now. The electrons that are going to be used in the bonding are going to be donated by only 1. And both of them, they are going to share it together. It's like covalent bonding, but don't forget that in covalent bonding, both atoms are donating and both of them, they are enjoying it. But in coordinate covalent, it is only 1 compound or it is only 1 atom that will donate the electrons that are going to be used, while the second compound is not going to bring anything and it's going to share with it and they are going to enjoy it together. Hope you are getting the point. So now an example of a compound that has dative or coordinate covalent bonding is, let's say, ammonium ion, that's NH4 plus. Also, hydroxonium ion. Also, hydroxonium ion also has dative bonding. So now let me use hydroxonium ion to explain dative bonding. I hope we all understand this. So, to know hydroxonium ion, you can see that it is actually water and hydrogen ion that are reacting to give us hydroxonium ion. So now let us try to draw the diagrammatic representation of both water and hydrogen ion. Let us start with water. Water comprises of 2 hydrogen atoms and 1 oxygen atom. Don't forget that I told you guys before that hydrogen has an atomic number of 1, while oxygen has an atomic number of 8. So oxygen has 8 electrons, right? Oxygen, it has 8 electrons. Oxygen has 8 electrons. That means in the first shell, it's going to have 2 electrons, and the second shell is going to have 6 electrons. Don't forget that I told you guys when you talk about bonding, you should talk about the valence shell. So we are dealing with the valence shell. Let us try to draw the diagrammatic representation. Let's say this is oxygen now. Let's say this is oxygen with 6 valence shell or 6 valence electrons. 6 valence electrons. So it's going to have like 2 lone pairs. It's going to have 2 lone pairs. You can see this. But let me explain it better. We are trying to draw water, right? And this hydrogen atom, 2 hydrogen atom. Don't forget that hydrogen atom only has 1 valence electron. You can see it has 1 valence electron. We are trying to draw how water is formed first. So now this hydrogen atom is going to combine with this oxygen. This one, you can see this particular electron, and this is going to come here. So we are going to be having something like this. 1, 2, 1, 2, and then 1, and then this is going to come here. Who can tell me what type of a bonding is this? The bonding that is in water, that is a covalent bonding, because these 2 hydrogen atoms, they are coming to donate their hydrogen, their atom, or let's say their electrons. They are coming to donate their electron to this oxygen, and oxygen is also donating 1 to them too. So this is actually water. This is water molecule, right? So don't forget that our aim is that we are trying to get the relationship between water and hydrogen ion. But we have already drawn the structure of water, right? So now, plus, let us draw for hydrogen ion. Now, see, this is hydrogen ion, H plus, H plus. What does the plus means? The plus means that it has actually lost one electron. Are you following me? Hydrogen ion, if you see plus in chemistry, when you see something like Na plus, H plus, anything, Cl minus, for plus, it means that it has lost one electron. Why for minus? That means it has gained one electron. So don't forget that our normal hydrogen is supposed to have one electron, right? It's supposed to have one electron. But it's going to be like this. Since it is now H plus, that means it has lost the only one electron it has in its valence shell. So it's going to be like an empty shell, like this, something plus. It's going to be an empty shell. So now, how will these two combine? They have to combine. Remember, I told you that dative bonding or coordinate covalent bonding is a type of a bonding whereby the electrons that are used in the bonding are only donated by one of the participating atoms or one of the participating molecules. So now here, you can see this does not have any electron at all. That means it has to come here. And if it comes here, this water is going to donate these two electrons for this one. Why this one is not bringing, this hydrogen ion is not bringing anything to the relationship. That is a dative or a coordinate covalent bonding. So we are going to have something like this. If we try to draw this water, if we try to draw it, you can see that this is this. We have this, we have this, we have this. Most times, don't forget, so this empty is going to come here, it's going to react with this. You get? So it's going to bring the positive sign. So you see, so we are going to be having something like hydroxonium ion. So that is how it is formed. Most times for a coordinate covalent bonding to occur, you need to have a lone pair, like an electron lone pair. When you talk about an electron lone pair, that means two electrons that are on the shell that are not participating in bonding. For this water has two lone pairs. You can see this lone pair and this lone pair. You get it? So this is how the bond between water and hydrogen ion is formed. And the correct answer in this question is dative or coordinate covalent bonding. You can see it in your chemistry JAMB exam, but they might not use the one for water and hydrogen ion. They might use the one for ammonia and hydrogen ion. That is how ammonium ion is formed. I believe this is very simple to understand. If you have any questions, you can drop them in the comments. I'll see you guys in the next one.